Monolithic and microservice architectures both have their pros and cons, and I'm not about to wade into the religious flame war that is the monolithic versus microservice debate. The purpose of this video isn't to explore those options. The purpose of this video is to assume that you've made the decision to use microservices and how CockroachDB can help you with a microservice architecture. In my experience, microservice architecture creates a bounded context around a database, meaning the only thing that can talk to that database for reads or writes is the microservice that owns that database. Now, in a distributed database like CockroachDB, you might not want to create separate database clusters for each of your microservices. That's too much to manage, and the costs might be prohibitive. I was recently playing with CockroachDB's Logical Data Replication, and it occurred to me that a really useful use case could emerge from Logical Data Replication's ability to replicate within a CockroachDB cluster. That's what we're going to be doing today, but first I'll explain my journey to reaching this idea. One way of architecting a database around a microservice architecture is to use a monolithic database, where every user and every service talks to the same database in a kind of Wild West fashion. This is by far the simplest approach, but it doesn't scale well. No one can be certain as to how the tables are going to be used, how frequently they're going to be used, and who's reading or writing what to the database. The next approach, and the approach I'm most familiar with, is using separate database instances with some kind of API interface between the databases. For example, on the left we have an e-commerce database with tables that are specific to e-commerce, and on the right we have a manufacturing database with tables that are specific to manufacturing. In the middle we have our API interface that's maintained by developers of each team. If an e-commerce developer wants to get product or stock information, they'll have to go through an API that has been developed by the manufacturing team that allows them access to the relevant tables, and vice versa. What we'll be exploring today is a technique called data copying, and that could look like this with logical data replication. On the left, we still have the e-commerce developer, and on the right, still the manufacturing developer. But this time, I'm copying tables between the databases so that developers in each team have a local copy of a table that's just for them. In order to get product information, an e-commerce user has a unidirectional copy of the manufacturing product table. So that's a one-way copy with no product information coming back the other way. But the stock table is different. That's a bi-directional link. The manufacturing developers might add new stock when stock is delivered to the warehouse, and e-commerce developers might deplete stock when it's added to baskets or checked out. And finally, purchase information. Rather than creating an API to expose it to the manufacturing developers, we copy the tables wholesale into the manufacturing database for the team to use in a safe read-only fashion. Let's create this now so you can see what I mean. First, I'll spin up a CockroachDB node, and then I'll create the tables that will be used. The tables themselves aren't pertinent to the demo, but you will see any query that I use to configure logical data replication. Next, I'll connect to the database and create streaming copies of the product and stock tables in the manufacturing database to the product and stock tables in the e-commerce database. I'm doing this validated so that we check for foreign key constraints. Next, I'll create the replication stream the other way, this time going from the e-commerce databases purchase item, and stock table to the manufacturing equivalent. So with this, we've created a bunch of unidirectional replication streams and one bidirectional replication stream for the stock table. Now I'll connect to the manufacturing database and insert some products. Let's say products are managed centrally from the manufacturing division of the company, and I'll create some stock. Let's say we've just received a delivery of stock for these products. Up here, I'll connect to the e-commerce database, and if I select everything from the product table, the products that I just added in the manufacturing database are available to me in the e-commerce database. So too is the stock. You'd still want to configure finer grained permissions to prevent e-commerce users from writing into these tables, but this should give you an idea as to how you can share data between teams within your organization. Now I'll create some data in the e-commerce side. I'll create some shoppers and I'll add products to their baskets. Notice the quantities of products are 1, 2, and 3. And then I'll call a function that I created to check out the products. This creates a purchase and purchase items and empties the basket. And because this is a bi-directional link, the stock in the manufacturing table will now be depleted. As a result, the manufacturing team know that stock has been purchased and new stock might need to be ordered. Logical data replication is an incredibly powerful tool in CockroachDB, and this is just one of the workloads that it enables. In a previous demo, I showed how logical data replication could be used for a 2 data center active-active setup. But because of its ease of use, it's just as suited for intra-cluster replication. In this demo, everything was done within the cluster itself, with no messaging platform or event system, and no data pipelines. Data for each microservice was logically separated. Give logical data replication a try and see how it might simplify and benefit your workloads.